In the past, people imagined dinosaurs as clumsy, stupid giants that barely moved across the land, covered in rough scales and incapable of complex actions. But thanks to progress in science, including the analysis of fossils, genetics, and comparative anatomy, our knowledge about them has expanded significantly. And now we understand a lot about their life, behavior, appearance, and even how they interacted with their environment. For example, it has become clear that not all dinosaurs were covered in scales without a single feather, although public consciousness is still full of misconceptions about these ancient creatures, from their appearance to their daily habits. Take, for instance, the most famous of them, Tyrannosaurus rex. In the past, it was depicted as bald, slow, and not very smart predator. But today, many think of it as a powerful beast with feathers, thanks to popular drawings, films, and even some scientific illustrations. However, this idea is not entirely accurate. In reality, Tyrannosaurus rex did not have feathers, although its distant relatives, such as Nanooksaurus, did. That relative was much smaller and lived in cold regions, where feathers helped retain heat, like a fur coat in Arctic conditions. In contrast, Tyrannosaurus and its close kin, like Daspletosaurus or Albertosaurus, inhabited warm climates where dense plumage would only hinder them, causing overheating and reducing hunting efficiency. These animals were active hunters with a warm-blooded metabolism, so their bodies already maintained a high temperature, similar to modern mammals. And this isn't just speculation. Scientists have found numerous skin impressions of tyrannosaurids, from the back to the snout and limbs, where the absence of feathers is clearly visible, replaced by a scaly structure adapted for thermal regulation in the hot forests and plains of the Cretaceous period. So if someone tries to convince you that the classic bald Tyrannosaurus is an outdated view, and in fact it was fluffy like a giant chick, you can safely ignore such claims. True paleontology enthusiasts know there is simply no evidence of feathering in Tyrannosaurus rex, and this is confirmed by direct fossil finds. Now let's talk about how this predator saw the world, because there are plenty of myths here too. In many illustrations, Tyrannosaurus is drawn with small eyes, and people often think its vision was weak, like a nearsighted lizard wandering in the fog. But in reality, it had the largest eyes among all dinosaurs, and even among all land animals in Earth's history, with a diameter of up to 30 centimeters, allowing it to catch the slightest movements from kilometers away. Thanks to this, it not only clearly distinguished details, but could also accurately assess the distance to a target, focusing on it better than we humans with our modern optics. Moreover, in scientific circles, there's discussion of the idea that some dinosaurs, especially predators, might have had even advanced vision, possibly with elements of ultraviolet perception. We know that birds are descendants of dinosaurs, and they possess tetrachromatic vision, meaning they see shades of 4 basic colors, unlike our trichromatic vision with just 3.
This expands their color spectrum, allowing them to distinguish tones that are inaccessible and even unimaginable to us. For example, ultraviolet patterns on flowers or plumage. If we assume that extinct dinosaurs like Tyrannosaurus had similar vision, and this is quite possible given the eye structure in their descendants, then in terms of perceiving the world, they surpassed us by far, seeing the world in bright, invisible to us colors. Of course, this is a hypothesis, but it's based on evolutionary connections and comparisons with modern species. Don't be upset. We humans are lucky with trichromatic vision, as many mammals make do with dichromatic, meaning just 2 types of cones in their eyes. And for them, the world looks like it does to colorblind people, without shades of red or green. And we, in turn, are colorblind compared to birds, who see an entire palette hidden from us. This logic allows us to imagine feathered dinosaurs with bright plumage. After all, modern birds are often colorful, from iridescent hummingbirds to shimmering peacocks. Even an ordinary sparrow, which seems gray-brown to us, might shine with a variety of colors to other birds, including ultraviolet markings for attracting mates or camouflage. So if you draw a feathered dinosaur in green or yellow tones, it would be close to reality based on how evolution developed coloration for attraction or camouflage in their visual world, where colors played a key role in survival. But let's dispel another common myth. Many think that dinosaurs were all cold-blooded, like modern reptiles, lazily basking in the sun and incapable of prolonged activity. In fact, evidence points to many of them, especially theropods like Tyrannosaurus, being warm-blooded, or at least having a high metabolism that allowed them to maintain a constant body temperature, like birds or mammals. This enabled them to be active hunters around the clock without depending on external heat.
Another stereotype is that all dinosaurs were gray-green, like in old movies, to blend into the jungles. But fossils show that their coloration could be diverse, from red and orange shades in some species to striped or spotted patterns for camouflage or displaying strength. Many people think that dinosaurs were all the huge ancient creatures that lived millions of years ago, including those that swam in the oceans or flew in the sky. In reality, paleontology knows of no fully aquatic dinosaur. There were semi-aquatic ones, like Spinosaurus, which could hunt in rivers using its sail-like spines for thermal regulation or display, but it still moved on land with powerful limbs for walking. And if you see a Mosasaurus, that's a marine reptile, but not a dinosaur, evolutionarily closer to snakes and lizards. The same goes for pterosaurs. They flew on membranous wings, but belonged to a different group, though they were relatives of dinosaurs with a common ancestor in the Triassic period. True dinosaurs mastered flight only in the late Cretaceous period, and we call their descendants birds, which evolved from small theropods, developing feathers first for warmth and then for flight. These creatures are close relatives, but confusing them with dinosaurs is like calling a bear a feline because of a shared ancestor in the evolutionary tree. Another misconception concerns the term itself. Dinosaurs are often called lizards after all. Even the word dinosaur translates as terrible lizard. But lizards are a separate group, Lepidosaurs, and dinosaurs don't belong to them, although all are part of the broader category of diapsids, reptiles with two temporal openings in the skull for better jaw mobility. Crocodiles aren't lizards either, despite superficial similarities in their scales and lifestyle. They're closer to dinosaurs in the archosaur clade. If you want an accurate term, call dinosaurs reptiles. That's correct for the entire saurian clade, which includes dinosaurs, crocodiles, and even true lizards. Some might say that lizard and reptile are synonyms, but no. Reptile is a broader group spanning millions of years of evolution. Calling a dinosaur a lizard is like calling a human a monkey. Not every primate is a human, but every human is a primate. Similarly, not every reptile is a lizard, but every lizard is a reptile. And since birds are dinosaurs according to modern data, they can also be called reptiles in a scientific sense, though it sounds strange to ordinary people, like calling a chicken a lizard. Paleontologists will understand. Birds are in the same saurian clade with shared traits like egg-laying and scaly legs. Now about the scale of our knowledge. Many assume that scientists have found almost all dinosaur species, but in reality, it's only about 1% of the actual diversity from the Mesozoic era, when dinosaurs dominated for 165 million years. Look at modern birds. There are thousands of species, and that's just one branch of dinosaurs, the Maniraptorans, with their variety from tiny hummingbirds to huge ostriches. Imagine how many forms there were in other groups, from giant sauropods like Brachiosaurus to small ornithomimids that ran like ostriches. The problem is that fossils are rare, and large specimens are found more often because their bones preserve better and are easier to spot in rock layers. Small and medium-sized dinosaurs often go unnoticed, decomposing faster or buried in less accessible places, so the picture is incomplete, and many discoveries lie ahead, possibly with new technologies like computer tomography of fossils. This leads to understanding how deeply the history of dinosaurs goes. You've probably heard that humans are closer in time